All right, so you were telling me yesterday, or 2 days ago, Dr. Gross on the phone, that while you first came to RCA to work on the light emitting on semiconductors, right? So who was it? You were at Syracuse?
Well, in Syracuse, I was at
Oh, you were at Columbia.
Columbia with Robbie.
You were a postdoc with Robbie working on, what was it, molecular beams, right?
That's right.
Okay, and what happened then? Who was going?
Well, Murray Lampert from RCA came to visit because he had an idea to produce infrared.
Okay.
However, he's a theorist and not experimentalist.
Mm-hmm.
So he's looking for a postdoc. Well, he made me an offer, but I had to go from Columbia to Princeton
Right.
every day.
Right. Is that like the Dickey train or something?
Yeah, but what happened
Dinky train, yeah.
But what happened is that the reason why he was doing all that, he had an idea of getting low field breakdown on semiconductors, cooled at helium temperatures, and if you put the field, the carriers recombined and produce infrared.
Okay.
But the trouble is with theorists.
And those were what compounds now? Those were what?
Germanium.
So they were 3,5 compounds?
No, just germanium.
Oh, just germanium first. Okay.
Then what happened is, so I had the offer to come to Princeton and help him. Well, when I came there, the trouble is, I was still living in Columbia.
Right.
So I had to rush and take the train.
Right.
And come home.
Mm-hmm.
And therefore, what he had liquid helium, lowering the temperature of germanium. Mm-hmm. So I did one day. And then, by the way, after they poured the helium, I had to catch the train.
Yeah.
And there was helium there.
It was really expensive then.
It was very expensive. I had to take the train.
Mm-hmm.
So they came back and said, you can't take the cab to go back. Well, there's helium there. It's so expensive.
Yeah.
So I said, you know what? I got a better idea. So what happened is, first of all, they offered me a job permanently at RCA. Not, instead of going back and forth to liquid helium, I thought I would take some semiconductors with impurities.
Oh, okay.
And then if you put the voltage on, it would break the carriers and combine again.
Right.
And it gave emission.
Is that because when you combine the impurities, you have a lower band gap, or?
Yeah, lower band gap.
Yeah. Okay.
But this was at low temperatures.
Right.
So RCA said, well, I'll tell you what, we won't waste helium anymore. You could work at RCA.
Okay.
So I started to do that, and I have pictures of it.
Right. And first you what? I guess you did the indium phosphide, right? And indium arsenide?
No, germanium first.
Germanium first, but then how did you get to the binary compounds, the 3,5?
Well, the 3,5. I had the idea of having different band gaps.
Okay.
So I'm getting a different radiation. Then it turns out that there's that control of this thing.
Yeah.
I can actually, aside from breaking down the radiation, it would emit and I can modulate.
Okay.
So it turns out when I would modulate, I could transmit the signal and modulate. Mm-hmm. Therefore, I could set up and I could transmit music out of the beam.
Well, no, but before you get the music, how did in 1955? That was 1957.
Right.
But the first setup you made that's in the photo that's scanned up there, it was in your notebook, 1954. That was your setup yourself, right?
That's right.
Maybe you collaborated with Murray Lampert, but it was you were the sole experimenter.
It was mine solely.
Right. And so who made the samples? Crystal Grower?
It was Skylar Christian, a few other people.
Skylar who?
Skylar Christian.
Skylar Christian, okay.
And then discovered that there's a lot of people who could produce different materials.
Right.
So I negotiated indium phosphide, indium
Okay.
arsenide.
Okay.
Therefore, I could really not only the visible, but I could communicate the infrared.
Right. So those were
3-5 compounds.
right, but those were binary compounds that were grown that way. Okay.
3-5.
3-5, right. And so the first experiment that it's in the 1954 photo, that's indium phosphide or arsenide?
Gallium arsenide.
Gallium arsenide. So that was gallium arsenide that gave off infrared radiation.
That's right.
In 1954. And the paper was written in 1955.
Yeah, I know.
Okay, that's what I'm making sure of. So that's that. So that's a photo of the setup, but you didn't play the music until 1957, right?
Right.
Okay, so that's not a photo of the music being sent. It's just
startup.
It's just the startup and the reflector which went to the detector.
That's right.
And you did the work at 77, but then you also found out it worked at room temperature.
That's right.
Which is referenced in the paper. Okay. And then let's see. So after you worked on you published the 1955 paper.
That's right.
Then what? You worked with Herb Kermer, or no?
Well, Herb Kermer was working with. Well, he had some other ideas.
Right. Those were the heterojunctions.
Heterojunction and whatnot.
Okay.
And then, because of that, the director of the laboratory gave more credit. Then he had a chance to get a university job.
Right.
So he went to Santa Barbara.
Right. No, but when you say he got credit for the heterojunctions, but same time, who did you work with immediately after you did the 1955 work? Do you remember?
That's some postdocs.
Postdocs. And you said you had a summer student that went to GE?
Yeah.
Who was that?
Can't remember the name.
Okay, I mean, I tried to find out if that was Rick Dill, but I don't think, he
No.
wasn't sure if it was him. Because Rick Dill said he went and knew Nick Holniak. He knew both. He may,
That's right.
but it wasn't Rick Dill, you think, Richard Dill, so, okay. But there's so pretty much, until you worked with Herb Kermer and Egan Lerbner.
Yeah.
So now Egan Lerbner, you don't remember, but in 1963 there is a patent.
Yeah, you know why?
Because?
He got a job, and he knew what I did.
Uh-huh.
So he issued the idea in the publication and didn't leave my name out.
So he gave you the credit in the patent.
No, he didn't even do that.
No, 1963 patent has your name on it.
Yeah, but that's it.
That's it. Right. But the point is that you don't remember in 1961 or 2, RCA and IBM and GE had a big fight over who had the precedence of the patent.
That's right.
And so I think I'm going to ask Mr. Gross about it, but it seems as if maybe because you had the first paper, you couldn't patent it, right? If you publish, you can't patent it.
That's right.
But the people in Texas never published, but they saw the emission. This is what Dr. Biard said. Saw the emission with an infrared microscope.
That's right.
So they kept it secret. And somehow they were able to prove their precedence to the 1950s for the patent. But, it's complicated, I mean, I'm sure those guys got the, whatever was done, whatever. I think everything was above board. I'm just trying to, I was wondering, you were kind of in the process of leaving RCA.
That's right.
And you may have moved on to other work, too.
That's right.
And so maybe you weren't involved in that discussion.
No, but the trouble is, when I was leaving RCA,
Okay.
I couldn't have a patent, but they gave me $100.
Right. So they wouldn't. Also, but by 62, 63, you were already kind of, interviewing here, right? Because you interviewed at the Science Center
Yes.
and RCA and UCLA and Lockheed, right?
Well, I had an offer to RCA David Sarnoff Laboratory in Princeton.
Right. I know that.
And when I left the other job, then they gave me $100.
Right. That's all you got for making the first infrared
The
LED.
trouble is that $100 was very worthwhile. So I went there. I bought my wife an Omega watch.
Who's right here.
In the local drugstore.
Okay. Which is still in the file. Yeah.
It turns out that when we finally ended up in New York, in fact,
Right.
in our temple, I met a family,
Uh-huh.
and we were out at Mort Deli one day talking about the future
Uh-huh.
of how he was at RCA and what he did,
Uh-huh.
and I spent the money, the whole story.
Yeah.
I said, wait a minute, you bought an Omega watch at the drugstore?
Yeah.
What's the name of the drugstore?
Yeah.
And I said, oh my God, my father owned that drugstore.
Huh.
So it turns out that the connections are done from Columbia
Right.
to Princeton to finally RCA. Therefore, it turns out
Mm-hmm.
that people discovered that my wife happened to meet someone one day
Right.
in the Palestinian Post.
Mm-hmm.
They said, you know, we heard a rumor that your husband had invented the LED.
Right.
So this Sue Pasco decided to interview Mother
Mm-hmm.
and want to write up a letter. So Mother gave an interview.
So now, right, and that's the article we can show. But I'm just curious. After you did the 1955 paper, did you presented that at the Physical Society?
No, I had other things to do.
You had other things to do. So even though it was interesting, it wasn't as important as say like the race for the laser.
No, I had other ideas.
In fact, that's the other interesting point we should bring up, which history's also talked about, that you knew about Gordon Gould and the candy store notary, right?
Yeah, but you know what?
Because he was next door to you in your office, right?
Yeah, but you know what?
What?
When I was at RCA,
Yeah.
at Columbia,
Yeah. Columbia.
I also decided to make a molecular beam.
Mm-hmm.
I have to sort of bounce some light. But the only thing is I did the cavity.
Yeah.
So I had the idea that I had a reflection that could make a cavity. Then that was an old idea.
Right.
Then Golden Gould said, oh my God, you can make a cavity with a ruby? My God, it's a cavity. I could make an oscillator that way.
Yeah. But he was a theorist or an experimentalist?
Experimentalist. So he finally ended up leaving RCA and going to Vancouver.
No, but you said Columbia, you mean?
Well, after Columbia, he came to RCA.
He was at RCA too, okay.
Yeah.
But you told me that he had the office next to you and that you thought there was this pump making this weird noise, and it was Gordon Gould thinking late at night, right?
That's right.
Or was it this like boop,
That's right.
boop, right?
Yeah.
Boop.
But Gordon Gould ultimately ended up in Vancouver, Canada.
Okay.
And the trouble is, when they finally had to figure out to give the prize for the Ruby laser,
Yeah.
they found the idea that I gave Gordon Gould.
Right, which you didn't write down.
That's right.
So you had it, like, your idea was not to make a laser, but it was to at least have a cavity.
Yeah, that's right.
Because you weren't doing a population inversion, right?
That's right.
It wasn't a population inversion.
No.
It was just to have more light.
Yeah, but you know what?
But it still shows that his idea wasn't in an entire vacuum,
That's right.
right? I mean, it definitely was an important idea of the maser was in 1958, I think.
Yeah.
And so people were trying to figure out what to do. But at RCA, you were doing the molecular beam. That was Columbia.
No, I was at RCA already.
You were also doing trying to do molecular beam.
Yeah, because, I got the job at...
Right. Oh, so in addition to working on the semiconductors, you were working on the idea of the molecular beams there too, at RCA.
I thought I would do that.
Okay. But you hadn't actually built the setup with the cavity, right? You just were talking about it.
No, wait a moment.
Okay.
I finally had the idea
Mm-hmm.
that I have a ruby rod,
Uh-huh.
and I'll make a cavity
Right.
and then people said, well, you know what? We're trying to drill all sorts of things
Uh-huh.
with light. I said, wait a minute. I could take a substrate and blast it with a semiconductor and blast a hole in it. And have pictures